All right, welcome to The Explainer. Today we're going to talk about a piece of tech that's, well, it's pretty much everywhere, but you probably don't even notice it. I mean, it's behind your pizza delivery, but it's also used in global crisis response. We're talking about Geographic Information Systems, or as most people call it, GIS.
Okay, so think about this for a second. You pull out your phone, you open up a navigation app, right? It's not just a picture of the streets, it knows about traffic jams happening right now. It knows about road closures, even where the speed limits change. So how on earth does it know all that and then stitch it together to give you the fastest route?
Well, the secret isn't some crazy complex magic. It's actually a really cool way of seeing the world. I want you to imagine taking a map of your town, but it's a clear sheet of plastic. Now imagine another clear sheet on top of that, but this one only has the roads drawn on it, and another with just the buildings. That idea, that simple idea of stacking layers, that's the key to everything we're going to talk about.
Right, so this whole concept of layering, that's the absolute bedrock of GIS. It's how we take a boring, flat map and turn it into this dynamic tool that actually helps us understand what's going on.
Okay, so let's build one of these maps right now. You start with a base map, just the geography. Now, let's digitally overlay a layer of all the roads. Cool. On top of that, another layer showing every single building. Then, let's add another one that shows population density, where people live. And for fun, let's add one more that shows real-time traffic. All of a sudden, when you see all those layers together, you start to see patterns and connections that were totally invisible before. It's like putting on a pair of magic glasses.
Okay, so we've got this idea of layers down. It makes intuitive sense. But what is GIS, like, officially? Let's get a little more specific here, because it's way more than just making pretty maps.
So at its core, a Geographic Information System, or GIS, is a system that's built to create, manage, analyze, and map all kinds of data. But here's the kicker. It does all this by connecting the data to a specific location on Earth. The really important word there isn't map, it's analyze. That's the superpower.
And this is how it works. You've basically got two pieces to the puzzle. On one side, you have the location data. This is just the where. The GPS coordinates, the street address, simple. But then you have the descriptive data. This is the what. What is at that location? Is it a coffee shop? What's the population? What's the temperature? GIS is the magic bridge that connects the where with the what. You know, what's really wild is that this super powerful idea didn't come from some Silicon Valley tech lab. Nope. It was actually born out of a terrifying crisis in 19th century London, where one doctor used the basic ideas of GIS to solve a really deadly mystery.
Let's go back in time. It's 1854. London's Soho district is in the grip of a horrifying cholera outbreak. People are dying and fast. The popular theory at the time was that the disease was spreading through miasma, basically bad smells in the air. But this one physician, Dr. John Snow, he just wasn't buying it. He had a different hypothesis. He thought it had to be coming from contaminated water. The problem was, how could he possibly prove it?
So he did something that was, for the time, absolutely brilliant. He got a map of the neighborhood and he started adding his layers of data. The first layer, he put a little dot on the map for every single person who had died from cholera. Then he added a second layer, the locations of all the public water pumps. And when he stood back and looked at the two layers together, bam, the pattern was just undeniable. The deaths were all clustered, packed tightly around one single water pump on Broad Street. He took his map to the local officials, convinced them to take the handle off that pump, and just like that, the outbreak in that area stopped.
I mean, think about that. Dr. Snow didn't have a computer, no fancy software. He just had a paper map, some data, and this revolutionary idea that if you map information geographically, you can see things you'd never see otherwise. You can literally save lives. And that whole process, having a question, analyzing the spatial data, and finding a solution, that is the beating heart of GIS.
Okay, so how do we go from what John Snow did by hand with the pen and paper to what your phone does in a split second? It really all comes down to how we translate the real world into a digital language that computers can understand.
Basically, in the world of modern GIS, there are two main ways we model the world. The first is called vector data. This is for things that have clear, distinct boundaries. Think points, lines, and polygons. So a fire hydrant is a point, a road is a line, and a park or a property line is a polygon. Easy enough. The other type is called raster data. This is for stuff that's continuous, that doesn't really have a hard edge. It's represented as a grid of pixels, kind of like a photograph. Think about things like temperature or elevation.
or even a satellite image. You can't draw a hard line where hot starts and warm ends, right? That's what raster's for.
And with just those two simple-sounding data types, vector and raster, we have built these unbelievably complex systems that are now just woven into the fabric of our everyday lives.
I mean, it's just exploded. From that one life-saving map in Soho, GIS has gone global. Today, there are literally thousands, and I mean thousands, of ways this tech is used in just about every industry you can possibly imagine.
And you see these applications everywhere once you know what to look for. A retail company uses GIS to analyze demographics and foot traffic to figure out the absolute perfect spot for their next store. A delivery company uses it to calculate the most efficient routes for its entire fleet, saving tons of time and fuel. Your city uses it to keep track of every water pipe, every street light, every manhole cover. And, in a crisis, emergency responders use GIS during a hurricane or a wildfire to map the danger zones and get help to where it's needed most, in real time.
So what's next? Where is all of this heading? Well, as we look to the future, the ability to understand our world through this geographic lens, it's not just useful anymore, it's becoming absolutely critical. Just think about the biggest, hairiest challenges we're facing. Climate change, for example. It's not just some abstract number about the planet's temperature. It's about geography. Where are the sea levels going to rise? Where will the droughts hit hardest? Where are the most vulnerable communities? These are all fundamentally geographic questions, and GIS is the tool we need to even begin to answer them.
So at the end of the day, this isn't just about making smarter maps. It's really a framework for making smarter decisions. It's about using the power of where to understand our world on a much, much deeper level, and hopefully to build a future that's more sustainable and fair for everyone.
And that kind of leaves us with one final thought. If you could create your own smart map, if you could layer any kind of information you wanted onto a map of your community or your country or the whole world, what would you look for?